This cube looks like a Rubik's Cube, but it has this one secret move. If we turn this middle layer 45 degrees, these parts line up, which means I can do this move. In this video, I'll scramble this cube and try to solve it. First, let's scramble it like a 3x3. So now let's try to get this out of the cube form. In my opinion, this looks pretty scrambled. Alright, so now that this is scrambled, let's try to solve this thing. So my strategy right now is I want to make this into a cube again, and then hopefully solve it like a regular Rubik's Cube. So right now the goal is just to get these pieces all flat. So in Rubik's Cube, the corners I think seem to be all the same as a regular Rubik's Cube. The only difference for the shape is that the centers and edges are a bit different. Some of these have two colors, some edges here have only one color. And I think that's because the centers and edges switch places. So for example, if I do a middle move like this, that should turn this into a center and turn this into an edge. But I guess there's another problem, that these edges are sometimes turned. So I need to figure out a way to flip them as well. Go right now, get the centers in the right spots and the edges in the right spots. I think we'll start with the centers first. I got a white one here. There's a green and blue one right here, so let me try to misalign this middle. Let's get the center up like that before we align this. Okay, I guess that's 3 centers solved. Okay, to get this to the top, I have zero idea how to do that. Or to even get this center down here, which is where I think it goes. Instead of solving adjacent centers, maybe solve opposite centers first. So get this blue center into here to make these opposite. Let's treat this as an edge by moving it up one, like that. And now let's insert this edge here. Okay, now the blue is opposite the green, which is perfectly right with the Rubik's Cube. So let me align that somewhere. Blue is now opposite green. The white's already in place, so maybe can we solve the yellow one opposite of that, which is right here. Okay, let's turn this yellow piece into an edge by doing a middle move. There we go. And let's put this yellow edge opposite of that one. Alright, now it's opposite of this one, and then if I move it down like that, we have yellow and white opposite. Alright, now we just need red and orange. Orange is here and red is here. Let me first get these two centers opposite of each other. This one is orange, so this one should be red. So just get red here. And that's pretty simple enough, just literally just one move. So now red is opposite orange. So red has to be here and orange has to be here. Because I don't want to disrupt the blue and green, let me put them to the side right now. So right now, all the centers are solved already, turn into edges. So they'll be preserved. Now let's get red to the front here with the middle move. Like that. And then orange will be in back. Finally, let's redo this middle move. Yeah, so these centers are all correct. Alright, so the next step I think is just to flip the edges. And I only have 4 of them, which I think is probably a bit lucky. And once I flip all of these 4 edges, essentially what I have is I think a Rubik's Cube, and I should be done there. Right now I'm trying to think about the logic of these and how they even flip. One thing I am realizing is that if I move the middle halfway, and then move another middle halfway, it can solve an edge. But obviously that messes up so much of the cube and all my progress, so I don't think I'm gonna do that. Random idea, let me just try to put all the edges together in one spot. Like this. So I'm wondering if I can use all of them on one side, do something, maybe? Okay, here's an idea. I can do the middle move right here, and then insert an edge from here to here. I'm wondering if this actually does anything. If I insert the edge, what happens? No, that's a horrible idea actually. That just messes up the center. It seems like every move that I want to do messes up the centers. So I'm wondering if even making the centers first is a good idea. Yeah, I'm completely stuck on how to flip these edges. Maybe, what if I put all of these edges into one slice? And then what if I do a middle move? I mean, similar problems. Oh, I just thought of something. If I do a middle move, these edges turn to centers. And centers are actually not too hard to flip. So here's my 3x3 and the logo is this way. And if you can't read Chinese, red should be on the bottom left. So I need to flip this 90 degrees. One way to turn this front side 90 degrees is I could do this. Let's repeat that series of moves 5 times, and notice how the red jumps from bottom left to top left. So rotate it 90 degrees clockwise. Since I know the algorithm to rotate centers, doing it on here should be absolutely no problem. I think this algorithm also rotates the top center as well as the front center, so I can try to multitask and flip 2 edges at a time. Well, edges I guess, but technically they're centers right now. So let's try to rotate these ones. Last move. And nice, as predicted, I flipped around 2 edges. And now let me just try to use the same algorithm to flip this and flip this. There we go. And then last move. Really surprising. It didn't take too long and we're already back into a cube form. Now that I think about it, parity is probably expected. So I guess I just cross my fingers and hope I don't get parity. But let's just try to solve this like a 3x3 now. Let me start with the yellow cross here, which looks pretty easy. Get this line. Add one more piece. Let me solve this block here. Insert this piece. And then the last cross edge. That works. Okay. There's a pair here. And then there's a pair here. And already something is showing up that I don't like too much. We have parity. The edges we have solved on top should be either 0, 2, or 4. Whenever we have 1 or 3, we have a parity error. Let me just solve the rest of the cube right now and see if there's other parities that can pop up, which I think is very possible. Yeah, we have PLO parity too. If you flip this edge around, it will be a K-perm, which is not a standard PLO. So let's do a J-perm. One flipped edge. And then 2 switched edges. So we have double parity, which is really unlucky for this solve. So I think it's really useful to understand what parity is and how it works. For example, you can have something like this, a flipped edge. This error happens when you do a move that's not a 3x3 turn. In this case, it's actually a middle turn, like this. Because the 4x4 adds this special turn, you can notice how these edges move around. Let's do it on this layer to make it a bit more clear. So this edge goes here, this edge goes here, this edge goes here, and this edge goes here. It's like a cycle of edges. And if you count the cycles of these edges, it's actually going to be odd. Meaning when you do one slice move like this, you change the parity of the cube. All this flipped edge means is that we have an odd number of slice moves. And to fix it, you also need to do an odd number of slice moves. Count the inner slice moves of the parity alg. It should be odd because that's how the alg works. And that's also because the edge flip is pretty much an odd number of cycles. This edge switched with this edge. Like that, which is only one cycle. In 4x4, these edges switch with itself, but on this cube, it doesn't really do that. In a 4x4, the extra variable would be that edges have 2 parts, 2 wings. In a Mixup cube, it's not like this, but there are centers on this cube. Before we could rotate centers 90 degrees, but we can also rotate centers 180 degrees. So if we treat this like a center like we did before, like this, and rotate it 180 degrees, like that, it should fix the OLO parity. Alright, let's try to solve this piece now. Generally the way I do it is to do 2 Y-perms. Red is on the bottom left here. I just do Y-perm twice. And that should move the red to the top right without messing up anything else on the cube. Alright, let's try to solve OLO parity. There we go, we fixed the OLO parity. Nice. Now for the final task, which actually might be a bit harder. That will be PLO parity. Now I can't use the same technique to switch 2 edges because on a 3x3 you can't switch 2 centers. The centers are stuck in place. So I'm really confused on how I can switch these 2 edges. I mean, my color scheme seems correct, so I don't think it's that. Alright, I think I figured it out. So in the 4x4, when I talked about parity before, remember how I said if you do one slice move, it changes the parity of the cube? You see how it cycles all of these wings, which makes it odd. What can I do that resembles that? Well, I think I could just do this. A half slice. And it has the same exact concept. The edge that was here goes here, the center that was here goes here, the edge that was here goes here, and so on. And just like on the 4x4, if you slice it one time, it changes the parity from even to odd. If I slice one time like this, it should change the parity from this, which is odd, because it has a parity error with the edges being swapped, to even, like this, which is what we want. Now notice that if we just move it back up, it changes the parity back to odd. So just doing that doesn't help us at all. We have to go back into the first step of the cube, which is solving the centers and then solving the edges. We want to preserve the even parity while solving the centers back to the correct spot and solving the edges back to the correct spot. Just like on 4x4, one slice does change the parity to even, but it doesn't really accomplish much on the cube. Well, the solution is actually quite simple. I just do the one slice, get into even parity, and then solve the rest of the centers and edges in even parity. So for example here, I can insert the green center here, and then insert the yellow center, insert the white center, and then so on. Pair up the edges, and eventually I should not get all of parity because I'm keeping it in an even state. Same idea here. I need to maintain its even parity state while solving the rest. So something about the parity state, right? If I move it here, it'll be odd, but I move it back, it'll be even. So moving it back and forth will preserve the parity state of the cube. Just like in a Rubik's Cube, if you move the middle back and forth, it will keep everything the same. Now, if in between this back and forth movement, I can take out an edge and put back in an edge. And what does that do? That can cycle some edge pieces without changing the parity of the cube. So in between the back and forth motion, let me take out and insert edges to get everything in the right spot. For example, I can get this edge to its right spot by being a center. So let me take it out. Now we slice, or half slice, put it in, and a slice back. Now again, we don't change the parity state because we moved it back and forth, so that's fine. But at the same time, we solved a center. I think we continue on. Let's get to center here. And we solved 2 centers. Alright, last 2. So as a result, if I've done everything correctly, the cube should still be in even state, the center should all still be solved, the edges magically were also solved. So we have an even state with this cube. So there should be 0 parities. Alright, now let's solve it like a 3x3. And right now I'm just praying that there's no PLO parity because I brought the cube to even, so it should not happen. Nice, we have a J-perm, which is a standard Divid 3 alg, and we should be done after this. Solved. Wow, that was a really fun solve. It took, I think, above 30 minutes, but that was still really fun. The difficulty in this cube isn't really too bad. For solving the centers and edges in the beginning, it's pretty logical and intuitive. The hardest part is probably the parity. I think Olo parity is pretty easy to understand. Flip an edge, which is the same thing as flipping a center. PLO parity seems a bit tougher to understand, but if you know how parity works and how you can just shift the parity with this one move, it makes solving the rest of the cube not too bad actually. So this puzzle is not too difficult. I would give it like maybe a medium difficulty. The turn quality isn't the greatest, but I think it's a really fun solve. I remember Red KB getting this cube for the first time, and this was the first Rubik's Cube I ever was really amazed by on how it was turning halfway like this. But I'm glad that one of the first puzzles I was amazed with, I finally have one, and I was able to solve it myself with relative ease. So that's it for this video. This is a really cool cube, and I'm really happy that I've decided to get this cube and solve it. Thanks guys for watching, and see you guys in the next video.